Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 8.6, comparing linear, exponential, and quadratic functions. We're going to be looking for 8 things in our notes. Half of those things are going to be on guided notes to give you. So let's go ahead and get started with that first piece. So before we start anything, we just want to make sure that we understand what each of these functions look like. Back in the first semester, we learned about linear functions. So that's just going to be a line that's consistently increasing. We also learned about exponential functions, and those exponentially increase or decrease, almost like if we put together a quadratic and linear, we get kind of an exponential where it is curving almost to a trend, and then a quadratic function, which is what we've been working on recently, which just has a U-shaped graph. Okay. So what we're going to be looking for here, and these are a part of your guided notes, the 4 questions on that paper that you just received. It says in exercises 1 through 4, plot the points and tell whether the points appear to represent a linear, exponential, or quadratic function. So what I'm going to have you do is to go ahead and pause the video here so you can try 1 through 4, and once you're done, click play to check your answers. Alright, so I'm going to go ahead and start with number 1, and I'm going to go ahead and plot all these points in number 1. As I'm finishing number 1, I notice that all of my points have something in common. They have an axis of symmetry, and so they're both symmetrical on either side of this vertex here. So if I connect all my points, this is definitely number 1 going to be a quadratic function. Let's go on to number 2. This is what it would look like after I plotted my points. And this one kind of went off the graph a little bit, so I estimated that last one. But notice how we are increasing over time at an exponential rate. So this one in number 2 is exponential. In number 3, let's go ahead and plot these points to see what happened. Again, in number 3, I go off the graph just a little bit, so I estimated the negative 2, 10, but noticing again, I have a trend of a line, and it is going down, so we would say that this one would also be exponential. And then for number 4, let's see what happens when we plot our points in 4. With number 4, it should be very clear that this is just a normal line decreasing over time. So we're going to call number 4 a linear function. Okay. So next up we have the different types of functions and why we could recognize them maybe in just a table rather than having to graph them each time. A linear function, the first differences are constant. And so you're going to be looking at your y values to see how are they adding or subtracting. So just maybe think about that. So add or subtract. For exponential function, the consecutive y values have a common ratio. With this one, you need to make sure they are either multiplying or dividing to find that common ratio. And then on a quadratic function, the second differences are constant. And I'll show you more about what that means. You can basically go ahead and eliminate quadratic, though, if you can already pick up on a linear or an exponential relationship. If it's neither exponential nor linear, then it's definitely going to be a quadratic. In all cases, the differences of consecutive x values will need to be constant, though. So that means like your x values would need to be negative 1, 0, 1, 2, 3, 4, or whatever, or however they jump up. The main thing I want you to get from here is these 3 bullet points. So just copy these down for number 5 in your notes. And then once you're done, click play so you can see how it's done. So let's go ahead and pause here to give you some time to write. Alright, so what we're going to do is just look at a few graphs and determine if they are linear, exponential, or quadratic. Okay, so the first one, we notice that our x values are constant, negative 3, negative 2, negative 1, 0, 1. Great. Now we just need to figure out how y is changing. I can see that 11 changes to 8 by minus 3, 8 changes to 5 by minus 3, 5 to 2 minus 3, and then 2 to negative 1 is minus 3. Because these have a constant difference, this is going to be called a linear function. For letter B, I see my x values are still constant up at the top. Great. And then letter Y, I'm noticing that 1 gets to 2 by multiplying by 2, 2 to 4 multiplied by 2, 4 to 8 multiplied by 2, 8 to 16 multiplied by 2. Since I'm multiplying, I'm having a common ratio, so this would be exponential. And I'm going to go back and talk about how to write functions. The last one, we notice that our x values are constant, but here our y values don't seem to be constant yet. Okay? If we go from -1 to -2, that's -1. -2 to -1, that would be +1. -1 to +2, that's going to be 3. And then 2 to 7, that's going to be +5. Okay? What this means, and remember we wrote down in the quadratic functions, the second differences are constant, so now you just look at these. The value from -1 to +1 is +2. 1 to 3 is also +2. And then 3 to 5 is also +2. So that was what I mean by the second differences, is once you find the first differences, find the differences of the first differences, essentially. So this one would be a quadratic function. Okay, let's talk a little bit about how to write a function, though. For letter A, we're starting with a linear function, and that just takes it back to what we've already learned in the past. Remember, we would want to find our y-intercept first, which is b, and that's going to be right here. So 0, 2. So this is y is equal to something x plus 2. The other thing we need to know is the slope. And remember, that was y2 minus y1 over x2 minus x1. So what I'm going to do is basically just do this. 2 minus -1 over 0 minus 1. So 2 minus -1 over 0 minus 1. That's going to give me 2 over -1, which is -2. So my function would be y is equal to -2x plus 2. Okay? With this one over here, I'm jumping up, multiply by 2, multiply by 2, multiply by 2, multiply by 2. Okay? Remember, linear or exponential functions need to be written in the form of y is equal to ab to the x power. So we just got to figure out what is a, what is b. Essentially, x is just going to be plugging in your values. Because we're multiplying by 2 each time, our exponential function would be y is equal to 2 to the x power, where we're just going to plug in x to get our y value. Since there are no x-intercepts for letter C, what I would do is just find the vertex, which is this middle point right here, because on either side, the x values are symmetrical. So if my vertex is 0, -1, the 0 represents h and the -1 represents k. So I can write this in standard form, or using vertex form. Remember, we have f of x is equal to a parentheses x minus h squared plus k. And I'll just plug in what I have. So I know k is equal to -1, h is 0, so I'm just going to leave that one alone. And then a is not affecting anything, so my function would be f of x is equal to x squared minus 1. So here are the last 3 that you're going to try. All you're going to do is just tell whether the table of values represents linear, exponential, or quadratic functions. Let's go ahead and pause here so you can try 6, 7, and 8, and once you're done, click play to check your work. Alright, so for number 6, we notice that 1 changes to 3, multiplied by 3, 3 to 9, multiplied by 3, 9 to 27, multiplied by 3, multiplied by 3. Since we're multiplying by a common ratio, number 6 should be represented as exponential. For number 7, we see 12 goes to 0, minus 12, and then 0 to 4, minus 4, and then 4 to 0. But these aren't going to have a linear function or linear differences. They're also not going to be any exponential differences. What I do know, though, is that I have 2 x-intercepts right here. And because my graph crosses the x-axis twice, I know that that's going to be a quadratic function. Or you just tried exponential and linear and neither one of those worked, and so therefore you have to have a quadratic for that one. The last one, we notice that 16 changes to 8, either minus 8 or divide by 2. 8 to 4 is minus 4 divide by 2, so but all of these are going to have divide by 2 in common, which means 8 would also be an exponential. Okay, that is going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.